Muito boa tarde mais uma vez, estamos de volta ao Waterworld Forum for Life. Estamos na belíssima barragem do Algarve. Está tudo a acontecer aqui, minha gente, tudo a acontecer. Se eu vos contasse o que aconteceu aqui durante o almoço, ficariam surpreendidos. O Vítor Gonçalves olha para mim e disse: tu nem pensas em contar nada. Este é o cenário absolutamente idílico que temos atrás de nós e do nosso estúdio de esportes náuticos a acontecer. Muita gente aqui à volta para não só usufruir destas experiências únicas que estamos a ter aqui no Water Forum for Life, como também para testemunharem as conferências, os debates e as conversas que temos tido aqui e que vamos ter ao longo dos próximos dias. Isto é lindíssimo, mudava-me para aqui na boa. Estão a ver aquela bolha? Era a minha casa, tranquilo, aquilo é um T0 gigante, parece-me muitíssimo bem. O evento que está a decorrer aqui em direto ao Algarve em simultâneo na internet, como já vos disse, onde, tal como o nome indica, discutimos a água, o mundo e a vida. Waterworldforum.com. Aliás, Waterworld Forum, exatamente. Waterworldforum.com. Por favor, partilhem nas vossas redes sociais esta conferência. Vamos ter grandes convidados, grandes conferências e acreditem que vai valer muito a pena. 3 temas tão vastos: mundo, vida e água, mas tão interdependentes que quase se unem num só. A paisagem é muitíssimo linda, mas é um facto que, como canta Sérgio Godinho, isto anda tudo ligado. E o tema da próxima conferência lembra-nos exatamente disso. O mal que fazemos ao nosso planeta acaba sempre por se virar contra a nossa própria vida, e a subida das águas é uma forma pelas quais esse desequilíbrio se poderá materializar. Poderá não, vai mesmo. A subida das águas do mar das cidades costeiras é já um problema evidente. Eu, que moro ali, na Cruz Quebrada, ali juntinho ao Rio Tejo, cada vez que a maré sobe, eu faço uma reza. A dizer, é desta, ainda não foi. Mas não adianta de facto fingirmos que não há um problema, que não há um elefante na sala. Não vale a pena continuar a empurrar a responsabilidade para a geração seguinte. O tempo de agir é agora e devia ter sido ontem, na verdade. Vários estudos fazem já previsões das áreas do planeta que serão atacadas nos próximos anos e posso dizer que já fui espreitar Portugal. A Cruz Quebrada está safa, mas é um bocadinho assustador. Não vos posso dizer qual é que eu acho que o barreiro, aquilo, não estou a brincar, estou mesmo a falar a sério que eu estou a estudar este assunto. Para perceber, mas temos cá especialistas para falarem melhor do que eu, para perceber em que ponto estamos e o que podemos fazer, o que ainda podemos fazer, que mais caminhos poderemos tentar para resolver este problema. Vamos então ouvir quem sabe, vamos ouvir o próximo painel moderado pelo extraordinário Vítor Gonçalves, que continua connosco. Vamos conhecer as perspectivas de Claire Dufau, especialista em monitorização ambiental da empresa francesa CLS, Susana Costas, do Centro de Investigação Marinha e Ambiental da Universidade do Algarve, o primeiro-tenente António Gonçalves Tavares, do Instituto Hydrographic da Marinha Portuguesa, Bruno Lucas, Remote Sensing Scientist da Agência Europeia EUMETSAT, e ainda Carlos Antunes, do Instituto Dom Luiz da Faculdade de Ciências da Universidade de Lisboa. Eu vou continuar a apreciar a paisagem e esta conversa. Vítor, é contigo.
Está já a filmeira e o que se passa no Algarve fica no Algarve.
Exatamente.
Well, good afternoon everyone. One major effect of climate change is the sea level rise, which might be a serious risk to coastal areas. That's the topic that we are going to discuss. And I will start with Carlos Antunes from Lisbon University. How serious is this problem, and globally and in the Portuguese coast?
Good afternoon to everyone. First, thank you very much for the invitation. It's of course a pleasure and an honor to be here. I would like to address 3 ideas before answer to your question. First is that sea level rise will depend how much the Earth will warm, depend on global warming. So the higher is global warming, the higher is the sea level, the higher is the rise, and most of all, the longer it lasts. Sea level rise depends on global warming, but due to the lower response of the oceans, it reacts very slowly. So we cannot expect that sea level rise will end at the end of century. It will keep going on, and the higher is global warming, the higher is sea level. So even if we limit the global warming to 2 degrees or 2.5 degrees, the sea level will keep going on, rising beyond 2100 for several centuries, even millennia. When we can consider, and we did it for Portugal, a scenario of 1 meter of sea level rise, some people criticize if that is possible or not. The problem is that it's not a matter of we reached that level. The problem is when it will happen. If it will happen before 2100 or 2100 or after. So the scenarios that we are using to assess the vulnerability of coast and risk are based on scenarios. So doing the assessment for 1 meter, we are evaluate and assess the risk and the hazard of such level. To answer to the question is, we all know that a big portion of population lives near the coast. We did it for Portugal, and we find that we have 14%, 1.4 million people that is living near the coast. How near? Just 2 kilometers wide. Globally, there's a published work that points around 19% of population lives on a 10-kilometer wide. But the most impressive number is how much people live between mean sea level and 2 meters of height. And the first number we had before was 200 million people. 2 years ago, the Climate Central, with more accurate data and precise data, came up with a new number, which is 3 times greater. 600 million people lives between 0 and 2 meters of height. Since we have the problem at the amplitude of tide, so 1 meter of sea level rise impact the life of 600 million. So these are numbers that we are leading with. The study that we did in Portugal related to assessment of coastal vulnerability, we find out for this scenario for 1 meter, 225,000 people live in what we call vulnerable area, coastal vulnerable area related to sea level rise. And there are some cities that have great numbers, like Setúbal, 60,000, Faro, 48,000, and Aveiro, 38,000. So we are talking about a huge number of human population that that is at risk.
Those are the 3 areas that are most vulnerable in Portugal: Faro, Setúbal, and Aveiro.
Are the districts that present the greatest numbers. The reason is because we have a dense occupation, human occupation on the Tagus estuary and lagoon systems, Aveiro and Faro, and Setúbal has 2 estuaries, the Sado and the Tagus. So there's a lot of population that lives on the low-lying areas that are very close to the intertidal zones of sea level.
Now I call Bruno Lucas. Bruno, how can we use satellites to monitor or tracking sea level rising?
Hi, Vítor.
Hi.
Hi. Thank you for having me. It's a pleasure to be in this conference. It's a pity that I cannot be in Algarve, but I'll try to give you my insight on this. So the way that we do to measure sea level with satellites is using a technique called radar altimetry. Okay, so the principle is quite simple. We have a satellite flying that has an altimeter. We emit a radar pulse, send it down to the Earth, and we receive it back, and we just count the time between sending and receiving this radar pulse, and then we have the distance. Because on board of the satellites we have a GPS, we know our location very precisely, we know our altitude very precisely about a given referential, And we can find out what is the height of the surface above that reference by simply subtracting the satellite altitude minus this range that we derive from the time. So that's that's sea level that we measure from an altimeter flag. The principle is simple. There's a few things that we need to take into account, like the electromagnetic waves are not traveling just through vacuum, they travel through the atmosphere. So we need to compensate for the different delays that come from the ionosphere, from the troposphere. That's why we usually fly with the microwave radiometer on board to account for these delays. Yes, I see that you're putting up my slides. So then can we go to the next slide, please? Yeah, so that was the basic principle of what I was saying. Next slide.
Bruno, are you listening? Me? Oh, okay.
Yes.
Are you?
Yeah, no, I was waiting for.
I have some difficulties listening and understanding what you are saying because the sound is not very good. But I think our viewers they watch and see you perfectly. But can you tell us if all the vulnerable areas around the world are right now covered by satellites, or this is not true?
Most of the areas are covered by satellites because the satellites are not roaming freely through around the Earth. They're following precise tracks. So these tracks allow us to monitor almost every area globally. So we can monitor at the global level what is happening in terms of sea level rise.
Lieutenant Gonçalves Tavares, now that we have satellite altimetry, how do we still need tide monitoring networks like the one that you maintained in the Hydrographic Institute?
Good afternoon. Thank you very much for having me here. It's a pleasure. Well, I think that's a really interesting and good question because some people start learning or hearing about these new satellites and the data that we are now gathering that cover the entire world, and they start to think, oh, so now we have these satellites, we don't need to go to the place we want to collect data and measure the data there. But that's not correct. And the first reason why is that we have to think that satellites, they are remote sensed based data. And so we are not measuring directly. And that is very good that we can have global coverage, but that comes with a price. We have to keep calibrating the sensors and validating the data. And to do that, we need to have these measurements that we call in situ measurements. And for the case of sea height, we need tide gauges that measure tides. And we are very proud in our institute that we have more than 20 tide gauges from the north to the south of the country, and also in our archipelagos that keep monitoring with frequencies from 1 minute to 6 minutes the sea height. And that can be used for this validation. So we can say that these two systems kind of complement each other.
Is it possible, let me interrupt just for a minute. Is it possible to say that one is more accurate than the other, or that's not correct?
It should be, because one is just measuring at one point, and the error will be less than if you are traveling to several layers of atmosphere, ionosphere, you'll have more errors. And so the one that we assume it's the right one, the tide gauges, helps correct the satellite systems. But we also still need to use these tide gauges, because if we think historically and for navigation purposes, we tend to install these tide gauges at harbors. Why? Because we need to know the tide. And we not only need to know and monitor the tide, but we also need to make predictions. And that's what we do. We keep monitoring the tide at high frequencies, and then we produce the tide tables that are available for everyone who needs them, from surfers to sailors. Another reason why we need this high-frequency data is because we can study local events, such as storm surges and tsunamis, also the sea level rise. We can compare this data with the data from satellites. And it's very interesting to see that they complement each other and they agree with each other. Our studies at the Institute from the tide gauges show that the sea level is rising at about the rate of 3.3 millimeters per year. And that's increasing every year.
Now I call Claire Dufau. Hi, Claire. Can you explain?
Hi, Vítor.
Can you explain how satellite altimetry can be used to inform decision makers about coastal flood risk?
Yes, of course. Thank you, first of all, and it's a pleasure to be here today in this panel. I'm an oceanographer, and I worked for years on satellite altimetry as presented by Bruno in the Environment and Climate Unit of CLS, which is a subsidiary of the French Space Agency. And today we are conducting a project for using satellite altimetry in combination with another satellite assets, namely the very high resolution optical imagery, for example, the Pleiad satellite images, in the framework of a project called Lithoscope, which is labelized and funded by the French Space Agency in the Space Climate Observatory Initiative. This initiative, I don't know if you are aware of it, I think you are. This is an initiative launched in 2017 and signed by more than 20 space agencies in 2019. And the idea is to promote the use of satellites to help the Earth to take decisions and to adapt and to mitigate facing the climate change. So what about the sea level rise? And how to use satellite altimetry and high-resolution optical imagery to estimate the coastal hazards. So what we do is that from this satellite altimetry, we take the knowledge of sea level rise, you have very well described before by Bruno and others. And we also take the opportunity to have some information regarding the land elevation, the coastal land elevation, to estimate the water height in the future years that will happen in the coastal areas. So it's a very important estimation to inform decision maker locally, to take a mitigation plan and to inform the people living in this area.
Can you elaborate a little bit more on how can we mitigate this problem?
You mean the solution that can be taken
Yes.
by these coastal territories? Unfortunately, I'm not the best expert on that. I'm not a decision maker myself, and I'm just providing those community information from the satellite monitoring side. So my role and my team is trying to push toward them the most interesting information and the most applicable information we get from satellites. So I guess that one of the mitigation action can be to relocate some of the activities in the coastal cities, or to take natural development to protect from the beach. But I think people in this panel will be much more expert for talking about that than me.
Okay, let's go to Susana Costas. Hi, Susana.
Hello, good afternoon.
Susana, which is the main challenge that Portuguese coasts are facing and will face in the near future?
Well, I think, and that will connect with the reasoning that Claire was presenting, and basically the problem of the coast is the ability to adapt, and that I could say it's a real big challenge because the coast is already going through a severe problem of erosion. A large part of the coast of Portugal is lacking sediment. So if on top of that we add the sea level rise, then we have a composite of problems, and the coast, in order to be able to adapt, that means that the coast has to have enough sediment to face the rise of the water, so the extra water level. And it has to adapt in the sense that when we talk about adaptation, we usually think about human adaptation, so the cities, as the title of this panel. But we also have to consider that the coast itself, I'm talking mostly about the sandy coast, no? Because it's a mobile system. So it has to adapt in the sense that it has to find the space where it can evolve despite the sea level rise and maybe the lack of sediment, which is the main problem that we are already facing at Portugal.
But do you believe that we will need to retreat some buildings from the waterfront?
Well, that is a political question also. So management and politics, sometimes they go they go a bit together, but indeed there are some areas that have already retreated in Portugal. And first it was easier when these second residence homes, but eventually we can only extend or face the reality. That means in some cases we have to retreat if we have enough resources to keep maintaining the sediment, so artificial nourishment of the beaches and dunes. And that means that we have to have the resources of sand that we can dredge from offshore or wherever, and the money, because it is expensive. So sustainable for how long?
Carlos, do you believe that is it difficult to convince political leaders and also the public opinion about this issue? Do you believe that people are aware of the risk that we are facing?
Yes, that is an important question. First, we need to have a good perspective and perception of the risk. The problem with the political issue is that the cycle of politics are different from the cycle of nature and cycle of climate change. About the possibility of mitigating the sea level rise is a complicated issue because the response of ocean, as I said, is very slow to react because it depends how much heat is stored on ocean and how the deep ocean will respond in terms of expansion, but also how much and how the glaciers at Greenland and Antarctica will respond to global warming. So, the time scale of these effects and this phenomena is a long time scale, is a long term. So it's difficult to address and to convince the politicians to do something. I've been working with municipalities such Lolé and Lisbon, working on assessment of vulnerability and assessment of risk, and we are now working what we call the adaptation emergency. The adaptation emergency depends on risk, which is related not just with the hazard, with vulnerability, but also with damage, but is related also with the exposure. So the problem that Portugal is more concerned today, as you asked to Susana, is more about erosion. But as I show you, I showed you, we have more exposure, human activities, human infrastructures that are exposed on the inland sea waters. And that is a great damage. So the perception of risk is difficult for politicians to see something that will happen in 50 years from now or 100 years from now. And it's difficult for scientists to convince politicians that we will reach 1 meter or 1.5 meters, that we have to remove an airport, or have to remove a Navy base, or a railway, or even a urban area. How can you remove a urban area with different buildings, apartments, which is a private private property and have rights, and is related to the long-term loans contract? So there's legal issues and political issues to address this question and decide in conformity to what we scientists know about the phenomenon.
Lieutenant Gonçalves Tavares, what could be the impact of sea level on the Navy installations that are mostly close to the sea?
Yes, well, so now we know that the global sea is rising. That's a fact. We didn't know that 20 or 30 years ago, but now we do. And as you mentioned, in the Navy, we have to be able to operate offshore. So we need to have our bases and facilities along the coastline. So we are probably one of the largest organizations threatened directly by this sea level rise. Unfortunately, we train every day against all kinds of threats, but there is one that we might not be ready to face right away, which is the climate change. We need to ensure everyone knows that it will happen. We have projections that show by the end of the century we might have 2 meters of increased mean sea level height, which it may not look much, but it is a lot. It is a very large number. And so I think we need to start planning strategically so that we can prevent that this sea level rise will not limit our operations or damage our installations. The plan, we have seen the US, they have started making such plans, and what they are doing is they look into all the installations that are at risk and then study one by one. And they evaluate the costs of doing nothing, the costs of the damage they will take versus the cost of adaptation measures. And so based on this, the decisions have to be made and we have to start working on it.
I'm going back to Bruno again. Bruno, what do satellite long-term records tell us about the sea level rise in last decades?
Hi, Vítor. I hope that you can hear me better now. So, on the last almost 3 decades, we've been flying satellite altimetry, and we've been doing this on the same ground track, so we can keep this historical record. And what we've been seeing is that we see a rate of about 3.3 millimeters per year on sea level. And this does not come only from one satellite or two, it comes from all the satellites, from different agencies, not only the ones operated by EUMETSAT, but also the ones from CNESO. All of them are showing the same trends over these years. We are seeing an increase of 3.3 millimeters per year. Maybe you can move to the next slide, Joan. Yeah, so on all these different colors, each color is a satellite, and all of them, as I was saying, are operated by different agencies, but they are showing the same trend of these 3.3 millimeters. Next slide, please. Then, I mean, if we aggregate those satellites into this global mean sea level, we see the line that we see on the screen, and this goes where we obtain the same values as presented before by Lieutenant António Gonçalves, of these 3 millimeters per year, and we have been accounting for 8 to 10 centimeters on total sea level since this activity was started in 1992. As was also mentioned by Carlos, this extra water comes from the melting of the ice of Antarctica in Greenland and from the ocean thermal expansion, because we are increasing the Earth's temperature, so the water expands with heat. Next slide. So here I have a map of Europe, and you can see that it's not the same value everywhere around the coastlines, but we can say that from what we have seen from altimetry, the increase of the sea is growing at a rate of 2 to 4 millimeters per year. So the seas in our coast are getting higher every day, and indeed sea level is rising at over 3 millimeters per year.
And that's it. The maps are very impressive, Bruno. Thank you. Claire, what are the accuracy and the limitations of the satellite monitoring sea level rise? Are there any limitation? This system is really accurate?
Sorry, I think Bruno could answer as well, but the instantaneous measurement of altimetry is very accurate, almost less than 1 centimeter. Regarding the estimation of the trend over the past 30 years at global scale, we have a very high accuracy of less than 0.5 millimeter, so 0.4 millimeter is the accuracy of this estimation. Unfortunately, locally, so Bruno just presented a map over Europe, the local estimation is a little bit less accurate, but it still is a good estimation. So we have a pretty good knowledge of this tendency, of this trend of sea level rise. And what we need now is to translate this knowledge into understandable information for the territories. So to translate this sea level rise into estimation of coastal hazard, so water height locally.
Claire, your company is located in France, right?
Right.
Is that correct? How French public opinion are concerned with this? Is this an issue in France?
For sure, we have a very long coastline in France, and more coastal cities are talking about that and are considering how to manage this issue. And we are currently working with, it's not big, but 2 of these coastal cities to demonstrate the useful side of satellite information for driving the decision.
So it's an issue in France. People are concerned. Do you believe that this is crucial to make politicians to act? I know that this is not a technical question, but I'd like to have your take.
I think it's crucial to let them know as much as possible the information we have in our hands, and it's the feedback we have from them right now when discussing with them, that they really want to understand, to be able to select in all the information they can read, heard, select where is the truth and how to go further with the social people and everyone, how to go further in mitigation.
Susana Costas, again, in the Algarve University, do you have several projects dealing with this?
With the sea level rise, the effect of the sea level rise?
Yes.
We have now we are working in a project. We are developing models to understand how the sandy coast reacts to changes in the environmental conditions. We are now doing tests also with a bit complex models to understand how the sandy coasts adapt to the sea level rise. Because there were some studies saying that most of the beaches will disappear by the end of the century or even earlier. But in many cases, the problem is that those studies are based on the application of quite simple solutions that do not include the complexities related to the adaptation. And we are working on understanding better how the coasts, the sandy part of the coast, meaning the combination of the beach and the dune, adapt to the sea level rise, and the possible changes in the climate.
Are you having a dialogue with the municipality? The University of Algarve, with local authorities.
And now we had small projects also with them. Because also Ria Formosa, which is the closest place with high risk that we have close to the University of Algarve, is located in a natural park also. So there are some plans that say or contemplate the fact that the Ria Formosa shouldn't have any buildings for residents. For example, it could have some support for swimming, for beach activities, tourism also, but not for living because of the risk associated to living in the barrier islands. Despite that, some houses have been removed, but there are still houses that are at risk in place. And yeah, the municipality is really concerned about that, and they are concerned. They need to know. They want to know how much they have, how much longer do they have, or how much sand do they have to put to keep to stay there. That is their main concern.
Thank you very much. Carlos, one last question, because we just have 1 minute more. UN Secretary General António Guterres was in the cover of Time magazine several months or last year, I don't remember exactly, with his feet in the water, and the title of the cover was Our Sinking Planet. Do you believe that we need more photos like that to convince people that this is a problem that the world, especially the coastal areas, are facing?
I think most of us think that we need more. That was a message. But some people didn't understand the message and keep denying that that's a real problem. Of course, he wants to made a message that the people that is less responsible for climate warming, as the Pacific Islands, for instance, they are the first ones to sink. So that was the message that he gave. In my opinion, yes, we need more messages like those.
Carlos Antunes, Gonçalves Tavares, Bruno Lucas, Claire Dufau, and Susana Costas. Thank you very much for your participation in this debate. I think it was really productive. Thank you again and good afternoon.